Today we discuss about simple machine. The idea that a machine can be decomposed into simple movable element led Archimedes to define the lever, pulley and screw as simple machine. But the time of the Renaissance, this list increased to include the axle, wheel and axle, wedge and inclined plane. The modern approach to characterizing machine focuses on the component that allow movement known as joint wedges. Perhaps the first example of a device designed to manage power in the handle X, also called by face and alloys. A hand axis is made by chipping stone, generally flint, to form a bifacial edge or wedge. A wedge is a simple machine that transforms lateral force and movement of the tool into a transverse splitting force and movement of the workpiece. The available power is limited by the effort of the person using the tool, but because power is the product of force and movement, the wedge amplifies the force by reducing the movement. This amplification or mechanical advantage is the ratio of the input speed to output speed. For a wedge, this is given by 1, where alpha is the tip angle. The faces of wedge are modeled as straight line to form a sliding or prismatic joint. Lever. The lever is another important and simple device for managing power. This is a body that pivots on a fulcrum because the velocity of a point further from the pivot is greater than the velocity of a point near the pivot. Forces applied far from the pivot are amplified near the pivot by associated decrease in speed if A is the distance from the pivot to the point where the input forces is applied and B is the distance to the point where the output forces is applied. Then A or B is the mechanical advantage of the lever. The fulcrum of a lever is modeled as a hinge or revolute joint. Wheel. The wheel is an important early machine, such as chariot. A wheel uses the law of the lever to reduce the forces needed to overcome friction when pulling a load. To see this, notice that the fraction associated with pulling a load on the ground is approximately the same as the friction in a simple bearing that support the load on the axle of a wheel. However, the wheel form a lever that magnifies the pulling force so that it overcomes the frictional resistance in the bearing. The classification of simple machine to provide a strategy for the design of new machine was developed by Franz Reulius, who collected and studied over 800 elementary machines. He recognized that classical simple machine can be separated into the lever, pulley and wheel and axle that are formed by a body rotating about a hinge and the inclined plane, wedge and screw that are similarly a block siding on a flat surface. Simple machine are elementary example of kinematics chain or linkage that are used to model mechanical system ranging from the steam engine to robot manipulators. The bearing that form the fulcrum of a lever and that allow the wheel and axle and pulleys to rotate are example of kinematic pair called a hinge joint. Similarly, the flat surface of an inclined plane and wedge are example of the kinematic pair called a sliding joint. The screw is usually identified as its own kinematic pair called a helical joint. This realization shows that it is the joint or the connector connection that provide movement that are the primary element of a machine, starting with four types of joint. the rotatory joint, sliding joint, cam joint, and gear joint, and related connections such as cables and belts. It is possible to understand a machine as an assembly of solid parts that connect these joints called a mechanism. Two levers of cranks are combined into a planar four-bar linkage by attaching a link that connect to output of one crank to the input of another. Additional link can be attached to form a six-bar linkage or in series to form a robot.